Not sure if Satish is already online, but you are perfect. So then I introduce you. So Satish Sandesa holds the degree of PE from the University of Mumbai in the field of instrumentation and control, and a degree of EMP from the Project Management Institute. He worked already in a lot of companies, starting from Reliance, Infosys, no-name Bosch, and then he also was part of Mercedes, the advanced driver assistance team, and finally he is now Vice President and Global Product Development Head of ADAS Validation at Electrobit. And I'm especially thankful that we have that keynote today, because it again shows the importance of the software in this overall problem space we want to cover. Beyond what we typically have, all these hardware details, the software is becoming more and more important. And I think with this keynote from Satish, I hope we get some more enlightening in this direction. And with this, I would like to hand it over to Satish.
Thank you so much. I will try my best. I'll share my screen. I hope you can. So I hope you can hear and see the slides. If you don't, please let me know. Cool. So thank you so much, firstly, for the kind introduction and also for the opportunity to speak. I want to speak about virtualization, and it's a bit ironic because I'm actually doing this virtually. So I'm sitting in India right now, and 2 years ago, if you had asked me if such a conference would have been possible virtually, I would have said won't be effective. So already the pandemic as a stimulant has indicated the importance of virtualization. So at least in daily business, I would have argued that working remotely or virtually would have been practically impossible in the business that we are in. But anyway, here we are. Before I get into virtualization in itself, I want to talk a little bit about the stimulants, and maybe it's a good idea to introduce Electrobit at this time, because this is not just a topic which is interesting for us, but it is also important for our business sustenance, if I can put it that way. Electrobit is actually a global supplier of embedded and connected software products and services for the automotive industry. We've been around for more than 30 years, and some of our software powers more than 1 billion devices across 100 million vehicles. We try to offer flexible, innovative solutions for car infrastructure software, connectivity, security, automated driving, and user experience and related tools. The reason why virtualization is also important for us is we are located in more than 11 countries, and our R&D teams are spread across at least 5 different time zones. Now, we can argue that with this background and heritage, virtualization is a topic that we are very good at. But I want to set the context and state that this is also a topic that we are trying to understand and comprehend. The global teams, of course, would love to work on virtual collaboration tools that help us to get faster, able to design and develop better. And yet we are asking ourselves how much of virtualization is an opportunity and what all is a threat. So I want to start really by talking about the trends that I've indicated in this slide. I don't have to explain, you know this, all of at least the attendees would probably already know this. I just want to reiterate that the impact on our business and economic models are real and definitely on the way that we work in the future. A bit of history. So the car was always supposed to be safe and dependable. Yeah. So these parameters that you see on the right of the slide are something known for us. We buy cars for a certain reason. So what is new? And the things that are new are good and complex. So our needs are changing, definitely increasing, and along with dependability. So I'm not just talking about in the case of a crash, my airbags deploy, I am safe, my co-passengers are safe. Now there is this new concept of security, and security in this case implies availability of my systems, especially mission critical systems. So I'm driving, let's say, in a tunnel or through a tunnel somewhere in the Alps, and for some reason, if my infotainment system crashes down, I can still get through the tunnel. But what happens if something else does not work like it should? So availability becomes critical, integrity as always, and then the concept of confidentiality. And with confidentiality, I'm talking about privacy. So data that I might want to share with my OEM, the brand that I have purchased, the data that I am willing to share in terms of my usage, things that we are probably already used to from a handheld device, a mobile phone, but things which are still new from a car perspective. The end user needs are constantly increasing. So, I mean, in the interview, Joachim was mentioning, so 16 years ago, I was working at Bosch and we were trying to develop the first series production Bluetooth car radio. And the thoughts and arguments and debates that we had then seems absolutely irrelevant. So we were talking about Bluetooth being a means to hack into the vehicle. Today, you have everything possible. You have DRSC, cellular. You pick anything that in terms of wireless communication that we potentially can think of, and somehow that will be either implemented or already implemented in the vehicle. So the possibility also to hack into the vehicle is quite high, which means that during the life cycle of the vehicle, the system or the product itself also needs to learn, adapt, and make us as safe as possible. And thanks to also this new age, our consumers expect seamless journeys between the devices, I mean the car and cloud. So in a very exaggerated way, vehicles are becoming smartphones on wheels. Of course, we are still on a safety critical mission. A car still weighs between 1 and 2 tons and can drive, at least in certain countries, around 200 kilometers per hour. So the software is transforming, enhancing our car capabilities, which is the cool part, but it is also creating complex development challenges for the OEMs, the tier ones and organizations that are in this industry. The systems are highly complex and must also meet the highest quality standards. A faulty software on a phone can be annoying, but a faulty software in a car could be fatal. So we need to work on an end-to-end approach that integrates independent software elements into a comprehensive platform that can improve functionality and hopefully decrease complexity. This is, with these changes, there are also demands in various other forms. So on this slide, I've tried to depict the vehicle networking architecture of the past, the present, and of the, I mean, this is not really a future. We are already talking about programs where this is being implemented. So from, let's say, hundreds of ECUs, we are coming to a point where we have a domain-based setup. With domain, we're trying to classify what aspects of my functionality resides where, what is mission critical, what is non-mission critical. We try to reduce the interference between mission critical and non-mission critical, so that we have at least the mission critical systems available at all points in time. Now, since I spoke about vehicle being a smartphone on wheels, just to draw a comparison, the last generation iPhone had typically one micro, one display, one proprietary OS, and I think 7 or 8 sensors. Compare that to a vehicle where you had hundreds of ECUs, and even in the future, you will have hundreds of sensors and actuators, or what we call a smaller form of an electronic control unit. There will be multiple displays and there will be multiple operating systems. And mechanical engineering is still a way to differentiate. which means how my car looks, how is it built, what is my aerodynamics. These are also as important as software. And therefore, faulty software, like I said, can be fatal, and our standards have to be a lot stricter for a lot of good reasons. Now, this brings the challenge to development organizations. So yes, there is privacy, safety, security, and now comes the facts. About 40% of the vehicle software is a differentiator, which means the remaining 60% still runs common functionality, which are required by all the vehicles. And this is regardless of the brand, the trim level. And we call this as a customer need for economies of scale, because you need to get to the point where you're most competitive and your cost position is better than anybody else. It's the remaining 40% where the vehicle software actually differentiates. These are unique functionality, specific for car manufacturers, trim levels, regions, in certain cases, customer groups. And this is what we call economies of scope. So the idea is to provide best support and expertise based on whatever is the differentiating factor. Now, with all of this, it is therefore imperative that we involve or we embrace technologies from a generic IT setup to take care of the market needs. So artificial intelligence, server-based vehicle network architecture, based software, service-oriented based software. These are all things we may have heard in other aspects of our life, but these are, let's say, our basic building blocks for us to go towards a connected and an autonomous thriving future. We must also understand that AI, by definition, is a learning ecosystem. It constantly learns. So to manage all our risks, once the car is out on the road, we must make sure that our AI implementation has seen most of the world, if not all of it. And this is where, let's say, the need for virtualization begins. So you may have seen this video. I'm trying to play it. So this is the Tesla autopilot, which mistook a moon for a yellow traffic light. Yeah, so seems nice on a slide with a video, but this is now our reality. Software-defined vehicles pose challenges that we have never seen before. So the explosion of complexity, the functional growth with the current architecture approach, really reaching its limits, the software complexity, and I read reports that the complexity will actually triple over the next decade. There are high degrees of variance. So there is enormous cost of integrating and upgrading the features that consumers are constantly expecting or increasingly expecting. And car makers face significant cost pressures. Let's look at it this way. If I'm going to own a vehicle for 15 years, across 15 years, I need to make sure that my vehicle is constantly upgraded with the software, irrespective of what was the hardware that I paid at the beginning. And yesterday already in the keynote, there was a mention which spoke about how adapting in software becomes a lot more easier than adapting in hardware, because consumers don't tend to pay, or end users don't want to pay for a particular hardware change in the vehicle if I can somehow get it for as cheap as possible.
For free.
For free, yeah. And the fact that my product also needs to be alive for 15, 20 years, despite the technology evolution, poses tremendous challenges for us as an industry. And as much as we've tried to standardize with AutoSAR, the standards are also kept maybe intentionally generic, and we can also interpret the standards in ways which is very individual. And this puts us all in a fairly difficult situation, given the fact that the time and money to manufacture a car or to put it on the road still remains the same. In fact, I would argue that maybe money is still the same, but the time is getting shorter and shorter, because we simply don't have now end users wanting to wait for 5 to 7 years before the next model is launched. You want updates on a continuous basis. You want the car to look different. You want the car to feel different. You want to experience new features. So the demands on the industry are really, really high. And that, having set the context, I want to come to what is it that we could do now in terms of virtualization. Now, before I come to virtualization itself, there are actually multiple challenges that we need to overcome. I mean, we spoke about how the industry grapples with the complexity, electrification, increasing autonomy of vehicles, consolidation of ECUs, our safety and security requirements, the fact that we have newer players in automotive. So you can now talk to companies which probably don't have an automotive heritage or a legacy. All these things coming together forces us to look at virtualization concepts in a number of ways to realize the vehicles of tomorrow. The challenges that I want to indicate in general even before we get to virtualization is first, of course, collaboration. So you need not collaborate, in which case you do everything yourself, which means it is fairly expensive for the OEM. We can get into defining joint standards. We have mixed results with how standardization has helped. We will see increasing collaboration between OEMs, tier ones, and the supplier ecosystem. I have some examples on the automotive OS in the coming slides. Validation and verification. This becomes, let's say, the most critical and crucial part of whatever it is that we are trying to do. All containing parts of the system needs to be validated to ensure smooth system integration. And the complexity and the extent of the system versus time to market creates a huge challenge, not just logistically, but also in terms of the qualitative parameters that we have for validation and verification. And this is also a key point to think about virtualization. The last part, I mean, sitting in India, I can tell you with attrition levels hitting the roof after the COVID pandemic hit, I think talent management. So the rising amount of needed software talents in automotive is already intensifying a war for software talents. So we are not exactly the first choice of software engineers coming out of the industry, and establishing our own software teams and retaining talent somehow adds to holding up further resources. So these are all some of the things that we have to keep in mind before saying that I can do this completely on my own. I don't need help from the ecosystem. With that, let me get into what we mean by virtualization. And I, with no offense meant, I really wanted to start with the Wikipedia definition. What does virtualization refer to? So in this case, it is just the act of creating a virtual version of something. And the something can be just about everything. So you can start with, for example, hardware virtualization. You can talk about software compartmentalization. I can create a digital twin of the vehicle. I can even create a virtual ECU to enable my development process. And I was reading through an article where apparently an OEM in central London has replaced its traditional sales dealership center with a virtual reality experience. So, I mean, in the introduction, we already saw about how the virtual reality for this forum has been set up. I think it's fantastic, by the way. So kudos to the team that set it up. But we are now talking about virtualization or virtual reality at an extreme as well. So instead of walking into a showroom and seeing a physical car, I now walk into a virtual reality experience theater and I see how the vehicle looks like. I can also hear the thud of the door on the speakers as I virtually close it. So the use cases are from the very basic to, in some cases, also very extreme, as you might think of. And that brings us to the point to say, what point in time do I need to look at virtualization? And I believe that we need to start with identifying our individual need. So I've listed a few, there are many more, of course, to explain what development lifecycle points to. So automotive has traditionally been a mechanical or a hardware-centric mindset industry. And if you're in a semiconductor company building, let's say, a subsystem, it's really hard to understand how your subsystem could be hacked into or broken because you're already too far down the path. So if you're looking at, let's say, the development lifecycle, you're probably already on the right-hand side. But from a virtualization standpoint, let's take an example of an automated driving system, and you're trying to detect whether you're going to run into an object or not. You can really think of scenarios of how someone accesses this part of my system. Maybe it's an external input to the system, maybe it's an access point from my operating system. The point is with virtualization, even before something goes wrong and affects the behavior of my automated driving system, I can model that behavior and try to identify at a system level from the hardware all the way through the OS into the application layer, which I couldn't have done it if I was, let's say, farther down into my development cycle. So that's maybe one need to start virtualization. Another is global R&D teams. So like I said, I'm sitting in India. My product development team sits predominantly in Germany and Austria. The moment we talk about geographically dispersed teams, we have to figure out smarter ways to work together. And it cannot just be a platform like Zoom or Microsoft Teams or Skype or whatever. We need to talk about also collaborative development and validation tools. And this already brings in the need for virtualization. I can give an example. So in April 20, towards the end of March 2020, India announced the lockdown because the COVID cases were rising. And I still had, unfortunately, about 10 people who had to come to the office because there was a very, very specific hardware dependence. So there was no way that we could virtualize it. And I could not even ship this hardware home because we did not have much hardware. And the situation hasn't changed much now because of the semiconductor crisis. We are not able to procure test benches, hardware setups that we would have liked to in the past. So globally located R&D teams is another need. Budgets, I mean, of course, I don't have to say much. At the end, every customer, each of our organization wants lower effort, shorter development cycles, lower BOM costs, and we want everything then to also work spectacularly out of the box and make us profitable. So this is also a need which will never go away. Then there is non-standardization. And what I mean here is, if you talk about virtualization, let's say a hardware virtualization or within an ECU or a domain, we need to talk about what is it that I can virtualize. And I have the next slide where I'll get into the details, but automotive OS, just like, for example, you have an iOS or an Android OS, is still a certain standard. Whereas if you're talking about virtualization at a hardware level, then we need to talk about operating systems. And in automotive, unfortunately, we don't have a standardization there. And we are still at the phase where we're trying to identify if an automotive OS is a differentiating factor for me, or is it something that I can reuse across my trims or model lines. And the fact that we have so many players in the ecosystem or the supply chain, parallel development is, you cannot avoid parallel development. So this is also another need for virtualization. And last but not the least, if you look at security, so if you take the other end of virtualization, you can talk about, for example, the digital twin concept, where you can completely set up the vehicle model digitally. Here, the entire system is virtualized out of models or simulations. And we have the possibility to test security features and address them from this perspective very early in the design flow. So companies which differentiate themselves on security or reliability need to also think about how can I left shift this so that I have the possibility to test and validate whatever it is that we're trying to bring onto the road. Next comes to the point of, so what does virtualization mean, or what are the examples? So one example, of course, is the hardware virtualization, or the most commonly spoken about. The picture on the right is just an electrobit hypervisor concept. So I just wanted to put something which gives the impression of what virtualization here really illustrates. Virtualization provides, hardware virtualization in this case, provides the means to combine previously separated systems on a single computing unit, on a single CPU. And it's basically another tool to model future functionality growth into a manageable in-vehicle electric and computing architecture. And those who have experience from non-automotive industries know that virtualization has been deployed at least for the last 20-25 years, if I remember right, across data centers. And we do this basically to improve the utilization of servers. We don't want some servers to be running at 100% load, some at 10% load. And the more effectively we utilize the servers, we need to keep in mind that this also costs money. So adding a new server is additional money. And it's not just money to procure the servers, but money to power it. And most importantly, if you walked into these big server rooms of larger IT organizations, you will see an air conditioning unit which is running at a capacity to keep the temperatures as low as possible. So we're talking about high performance computing of a completely different magnitude. Now, this concept is becoming crucial in automotive as well due to everything that I spoke about earlier. So the trends, the need for artificial intelligence, higher processing speeds, connectivity, so on and so forth. And hardware virtualization for us is a way to create multiple virtual instantiations of the same hardware, and every instance is, let's say, virtually dedicated to a specific hardware. You need to have the possibility that via the hypervisor, you're speaking between the virtual machines, as is listed in the slide here. You also need to have possibly each virtual machine hosting a different operating system. The complexity is really dependent upon what is the OEM need. But the important thing to keep in mind is when we implement this, you have the possibility to set up a native environment, and virtualization enables the concept of VMs, each having their own personal view of the real hardware. And with hypervisor assisted by some special hardware features, you can already set this up. So if I have to draw an analogy from let's say, the traditional IT world, what a kernel does for functional processes in an operating system, the hypervisor does for the whole OS and their kernels. So the hypervisor decides how each operating system and its functional software can share the execution resource of the hardware, and provides a view that the hardware enables each VM independently. So you can run it like you own that particular piece of hardware. Now, we have the possibility to partially or fully attain hardware virtualization. I know of use cases where we've tried to partially do hardware virtualization. So an example would be that, let's say you have two displays, a dashboard and an infotainment system, and you have just one let's say, graphic processing unit or a GPU, and then you run it through a partial virtualization would be that you set up a software switch, and the switch decides where do I want my display to be loaded. There are, of course, disadvantages of doing that, but this is just an example of how we can already talk about virtualization. Now, the most important part of virtualization is to identify what is my basic building block. So what is the extent, what is my risk-taking capability, and what are my safety and security maximized requirements. And there are many ways that you can, many parameters that you can use. We've listed a few that we do within Electrobit. The first is a mix of real and virtual components. So here I'm talking about designing an integrated system that has real as well as virtual objects that work together in what we call near real time. Yeah, this could be, for example, your system on chip all the way up to the complete vehicle being modeled virtually or in a simulation. But we need to keep in mind that this setup needs to be designed based on the need for the depth of details and the diversity of use cases. I mean, like we saw in the Tesla autopilot, maybe at that point in time, we weren't even aware as developers or as testers that maybe we could have a day where the moon looks like a yellow traffic light. Yeah, so maybe these are all very specific conditions that we need to now be aware of. But the idea of the mixed real and virtual setup is basically to mirror the real world scenarios as best as possible. And we also believe that this allows for a lot of software front loading. And as long as you describe or detail your platforms, your products, hardware and software in a unified manner or a common language, like I said earlier, we have the possibility to even analyze what if trade-offs. So in a repeatable and reproducible manner for decision analysis. Of course, here a lot of collaborative design needs to happen. So I need to have a single communication media or window that describes my system behavior. It is easier to speak about it than to implement it, but this is something that we need to keep in mind. We know that software is already an important critical part, if not the most critical part of the automotive platform, and such a verification environment must enable us to left shift the development of software so that you have the possibility to identify challenges much early in your development cycle. And I also have read papers and heard from organizations which are already looking into integrating vertical functionalities into an SoC or a system on chip solution, thereby repeating the benefits of left shifting and of course improving efficiency and quality. Identity creation. I think this is something, this is in my view a paradigm shift, and I come to this from the perspective that automotive has the world's largest and probably the most fragmented supply chain, with concepts of cybersecurity now to address automotive specific protocols and the challenge of securing millions of mobile endpoints and hundreds of millions of lines of code. The need to create a sort of identity or character for what you sell becomes very, very important. And car manufacturers will almost procure what is most suitable for their vehicles. Therefore, we need to leverage our virtual platforms with compatibility and feasibility, which means that we should be able to very clearly illustrate how our deliverables are ready and at what point at what level of integration can you use them. So we need to characterize whatever it is that we are doing as a deliverable from our perspective. The last part is ECU to cloud. So I mean, the more I could speak about this topic for hours, but the idea is when you have a global team, you need to have a design, development, and a verification platform that enables the team in a cost-effective fashion. Testing and verification is no longer a time-driven process to ensure certification and acceptance of our products. We need newer, reliable, efficient ways. So there was talk about test-driven approach as a concept. It doesn't matter what is our development model. We need to understand that our design and verification platform should be an enabler. And we also need to keep in mind that automotive is no longer a traditional industry where you have the same names that dominate the supply chain. There are non-automotive suppliers who have been fairly successful, let's say in the consumer electronics area, who come into this industry with a very software-centric mindset. I think Tesla is a very good example. And when you have a software-centric mindset, we also need to figure out how we can learn or integrate this process into development of a car. These are pictures from my product development setup. So we were trying so we have a rest bus simulation, a real rest bus simulation, and we are trying to see if we can move the rest bus simulation into a virtual setup. And I want to share an anecdote here. The funny part was we had a situation with one of our customers where some things weren't working in our hardware in-group setup. And then after hours of debugging, we figured out that we plugged in the wrong Ethernet interface. So instead of 100 base T1, we plugged in 1000 base T1, and voila, nothing was working. The point I'm trying to make is we need, as individual organizations, and of course, based on our interactions with our customers, identify what do we think we can virtualize. Maybe a point to keep in mind is, of course, we need to work together with the semiconductor industries, I mean, the system on chip solutions, or even the instruction set architectures that they define, there has to be a very close collaboration, because the instruction set architecture defines the behavior that of the machine code that runs on computing devices in our vehicles today. I mean, if you take automated driving or an ADAS SoC, then there is heavy dependence on the ISA that we choose based on the component supplier. Therefore, to virtualize, if we want the best outcomes, then such a specific code for my device under test must be able to also perform exactly the same way in a virtual environment. So these are just some things for us to keep in mind. Is it as easy as I'm trying to explain in the slides? Absolutely not. We have very specific needs as automotive, and rightly so. And we are going through a time which is also asking us more questions than providing answers. And last but not the least, technology is evolving at a pace that we have not known. So if it takes, for example, an OEM to 5 years to bring a car on the road, including R&D and production or manufacturing, people are looking at the vehicle and saying, oh, 5 years, I don't know if in 5 years, maybe the car even connects on a 4G, maybe I need to have a 5G or an exaggerated 6G or whatever. And you need to now prepare your vehicle to compute certain things at real time. There was, I mean, not so long ago when I bought my first car, computation inside the vehicle in India at least was not heard of. Today, your vehicle is a computational device, and therefore we need to think about what all do we need to bring in to my system. And the problem becomes much more difficult without standardized solutions. An example is the automotive specific operating system. Yeah, so it's the job of the OS to handle a large number of unique safety, security, and even complexity requirements in our space. But it's harder to accomplish this with competing proprietary operating systems. You can ask the question, why doesn't each car have its own operating system? The answer is clear, it's very expensive. And second part is, then why don't we come together as an industry and think about a car OS or an automotive OS? So these are some questions that we need to answer, but it is not something that we can do this ourselves. So each organization, of course, needs to figure out internally, what can I do in this ecosystem? At least at Electrobit, we were asking ourselves, will my current portfolio even exist if I don't virtualize certain things? I mean, the rest bus simulation example that I gave is one classic use case. And that relates to my business needs and portfolio. What do I need to virtualize to ensure I exist and I am profitable in this industry trend? I also personally believe that there is a big role from the ecosystem, and I would classify the ecosystem needs at least in 5 parts. So the first is the OEM. So the OEM needs, what can they accept as virtual in order to help them reduce their time to market and reduce, let's say, overall development or even BOM costs? Do I need to drive for millions of kilometers before I say that my system works fine? Next is the often forgotten legislation. Yeah. So what local legal support do I need? An example is maybe an intelligent traffic light system, which is an example of V2X communication, where the traffic light tells you that, okay, I'm going to be green in 10 seconds. Why don't you slow down? Now, this is not just an automotive use case that sounds nice. Certain countries or even, let's say, local corporations might be interested to reduce emissions by doing such a thing. So you don't allow stop and go traffic, for example, or you reduce stop and go traffic. How can we collaborate in such use cases? Will, let's say, let's say this is implemented in India in a city. Can I speak to my local legislator or local government body and tell them, I would like to do this, but I cannot come to that one junction where you have this intelligent traffic light system. Can I simulate it? So there has to be a certain collaboration also with the ecosystem, with the legislations. Then there is community initiatives. So what are we doing as an industry together? So an example of a positive example that I can point out is targeting virtualization is the Automotive Virtual Platform Specifications, or AVPS, by Genevi. maybe we need to look at it and say, how can we contribute? How can I benefit from that? My fourth part, my fourth reason in the ecosystem is collaboration. And building on the automotive use case example, doing it alone, maybe there might be some companies that might still do it because they are cash rich. But even if you have the cash, do you have the software competence available in abundance? And again, I'm trying to explain it this way, that a young university software engineer coming out of education may not necessarily be looking at automotive as my future industry. So in which case can we look at partnerships? I mean, I already heard in the introduction this morning about academia coming together. What can I collaborate with universities? How do I make use of academia to address some of these issues? And last but not the least, my fifth point is for us to learn from other industries. So I understand that industry comparisons are best avoided. I mean, I don't want to get into a debate of if my smartphone is as smart as my car, things like that. But it might be necessary for us to learn from, for example, how aviation is managing with its standardizations, or how consumer industry or the consumer electronics industry is tackling some of these new age problems. We may still have the luxury to pick and choose in the automotive world today, but I believe that once we have more and more non-automotive players, the traditional way of design and development may not be so easily accessible as we know it. So I'll spend the last few minutes talking about virtualization within my organization. Again, I want to reiterate that we are by no means claiming that we understand virtualization. We are also experimenting like a lot of the other organizations, and we're also looking over our shoulders to identify if what we're doing is right. Our goal within Electrobit is to come to a virtualized ECU development, which means we want to have an end-to-end tool chain for distributed collaboration. Of course, this means we need to enable virtual work environments. So traditionally, you get an AutoSAR XML file, ECU description file, which talks about the vehicle architecture, the entire vehicle architecture. This is at the moment imported into, let's say, a laptop or a desktop, and each of these developers must run or developers or end users must run a license of this tool. Yeah, so this also, I'm trying to indicate that the licensing models also will change, assuming I want to move to a cloud service. We may not be, Electrobit also now needs to think about, do I have to sell a per MAC address license, or can I talk about subscription models? So this is also forcing us to change beyond just technology. So it's not just a testing problem or a development problem. It's a business model change also for us. And of course, we're trying to see what all can I virtualize. So allowing my customers to focus only on major function development and use cases, so that we take care of the hardware, the operating system, the middleware, and of course the validation environment. So the validation environment needs special mention, because these are parts that you may have or we may have already heard of or doing it. But the validation environment is probably the most crucial, because we don't yet have an environment where we can do this across organizations. So from an OEM to a tier 1 to a tier 2 company, all using the same virtual environment is not yet heard of. And this is also something that we need to think about as an industry or as a group. Of course, we want to accelerate vehicle development with ECU virtualization. And we are looking at all of whatever I said. So virtual micros, virtual ECUs. Can I have a virtual system of ECUs or domains? Virtual car where possible. And this journey for us started some years ago, and we have a product use case that I will come to a bit. One of the needs that we had from our customer, one of our customers was, look, we are into the automated driving space. And if I have to launch an ADAS vehicle, then I'm looking at potentially having to drive millions of kilometers on the road before I say that it is working. So how can you help me in such a scenario? And that's where we've taken, I mean, it's not exactly vehicle virtualization, but this is where we are trying to say that whether the vehicle is driven physically, I mean, in real time, or you have a drive simulation software, you have the possibility to ingest the data, store it on a cloud. You can perform some data management, so enhancements, annotations, labeling, and you have the possibility to search for the data whenever you need. So this is basically a cloud management, a cloud-based data management interface for automated driving, and it efficiently orchestrates petabytes of test drive data to validate your algorithm. So you don't have to go around driving, finding, let's say, a rainy day or a road which is full of gravels. You have the possibility to just pick it up from your scenario database and rerun it on a platform. Again, by no means are we claiming that we have all of this by ourselves. We are talking to partners. So we already have our current demo that you can go to our website and see is based on one of our partners. But the idea is that we optimize data and storage management. We simplify global collaboration. You can easily find the data you want. You unlock scalability through the cloud. And once, let's say, you collect real-time data, you put it on the cloud, and somebody in a different part of the world can already pick the data. You're not coming back to the office, taking your let's say, the car PC, connecting it via a storage device to your Hill system, and then checking if the algorithm or the device under test works or not. And of course, the goal for us is to profit from an open design. Having said that, now I want to conclude, and I want to summarize by saying that the software-defined car is one of the biggest disruptions we have seen, and I do not believe that there is any way around investing in topics for virtualization and to build environmentally friendly, connected, safe, and secure cars. Test and verification platform is one clear example of how we can overcome these challenges. We are not there yet, but I believe that we are on a good way to overcome these challenges. So I will stop here and take questions if there are any.
Oh, thank you, Satish. Yeah, that's basically now up to the audience to raise the questions. I think there were some questions and answers posted. Not sure if you can see them as well.
I am trying
There's one from Jakob Engblom, but that's fairly long. I think he's asking about the model that you mentioned, that software that is running today on the car should also be, or the hardware should also support software which is coming down the road. And of course, that's a certain requirement to the hardware to scale to that. And he is asking if you see a trend when the classic model finished, just try to find the real, or maybe Jakob can unmute himself. That's easier, maybe.
I am trying to figure it out, but it looks like I have a problem with my browser, so I'm not able to see the questions myself for some strange reason.
Yeah, I think he compares it to Android phones, that it's also probably an incentive to buy a new phone when the hardware is no longer supporting the latest version of the OS. And then how do you see this applied to cars?
Oh, it's a very good question. I don't know if I have a good answer. So I can give you a technical answer. It would be best that the end user recognizes that at some point in time, my software changes or upgrades will also mandate a hardware upgrade. But this is not a paradigm that we are seeing yet. So I don't know if, I mean, we can solve this problem technologically or technically, but it may not be something that a user will accept on its own. So just like we upgrade mobile phones every couple of years, I don't know if people are willing to go back to the service station and say, hey, I have a brake pad problem or I have a wiper problem, please change it. And in the same way say, no, can you please upgrade my hardware? But by the way, it will cost you $1,000 for a euro. So I don't know if this is something that we can already predict, but we are hoping we go in this direction. This is where maybe we need to talk about different business models like subscription-based business models so that car manufacturers uh, can build in such upgrades in their warranty or maintenance.
Okay. I think that answered a little bit the question that Jakob had. Another one is from Christian Macaro.
Yeah,
he's asking, you see it now?
I see it now, yeah. So
okay.
How do you see the exchange of executable models across the supply chain with regards to with respect to virtualization? Can this be an enabler? Yes, it can be an enabler. I think that we have to somehow come. I mean, I was speaking about at least the point where we create an identity. So we have the possibility to understand at what point in time in my supply chain can I integrate it, and we need to create such access points as visibly clear as possible. Um, I mean, with models of integrated circuits such as sensors, I think it's again a very good use case for us to think about virtualization. I believe it's an enabler. It just needs to come to the point where we accept this as a potential enabler and move towards virtualization in this direction. I believe the ecosystem is still scared or worried about the impacts of what happens if I virtualize certain components which I believe are mission critical. And I truly believe that we can definitely use this as enabler. The next question again from Yakub: how long do you support software releases for a car? It's the same. I would like, I mean, as an end user, I want it for the 15, 20 years that the vehicle is alive. I don't know. I believe for this now, the entire ecosystem needs to undergo a change. So if I draw parallel from again consumer electronics, the first time I bought a smartphone, actually I got it from my previous organization. I was really struggling to find out what do I do with it. And then I got a message which said, oh, if you want to continue using this app, you need to pay, let's say, €1 per month or something like that. It was difficult for me. And I can tell you that for 2 years, I resisted spending that €1 per month because I thought, why do I need to do it? I mean, this should be free because I've already got a smartphone. And then I switched to an iPhone, and I recognized that if I don't change my behavior, my mindset, I will be left behind. I mean, I can tell you, my daughter uses an iPhone 7, I think 6 or 7. And after multiple upgrades, now they've disabled the Touch ID, forcing her to upgrade. So maybe we need to think about some things which are also acceptable in the industry. So I don't know. I mean, it's really a mindset change for us. And like somebody was already saying, we want everything for free. And maybe that needs to change. So that's the only way that the industry can survive, because the margins that car manufacturers work with is wafer thin. Yeah. So it might be easy for me to say that I want to buy my next vehicle at a 20% discount, but I want all my connectivity features. Being in the industry, I think all of us will already recognize that being profitable is not so straightforward. Then there's a question from Martin Barnasconi. So there seems to be a clear role for standardization organization to develop standardized and open APIs. Which organization do you consider key in developing an open and standard ecosystem? I don't have a preference for the organization. I just believe that, I mean, I gave the example of Genevieve, which is doing something in virtualization. Of course, we've heard about AutoSAR in the past. And still, I mean, with regards to cybersecurity, there is already some work going on. And I'm speaking now in a personal capacity. My current challenge with standardization is standardization also is only to a certain generic level. The implementation is still open to interpretation. I know that at least AutoSAR said that let's cooperate on standards and compete on implementation. How the end OEM or the vehicle manufacturer understands standardization is still not transparent. And what I sell for one OEM most definitely cannot be sold to another OEM, even if it is a standard-based implementation. So I don't know if I can refer to a body or an organization which does this. That's why I was trying to tell in this slide that I think as an ecosystem, we need to find alliances and collaborations. I think this will become very critical. And I somehow expect one OEM to have its set of dependable suppliers or supply chain and somebody else competing. For example, you can look at AutoSAR versus Jaspar. So Japan versus Europe, for example. So there's no clear answer, unfortunately, for this question, Martin. Then the next one from Jakob, how many different models might you need, models of components? A function accurate model that can run code versus a timing accurate model for performance versus an abstract model that just simulates behavior at a high level. Now, this is a very use case specific question. If you get into the the depth of the detail, I would argue that an abstract model is not good enough. But if you're using an abstract model only to state that, look, I have a certain percentage of my system that works fine, that is acceptable. The reason why I mentioned about, for example, the instruction set architecture or the system on chip is because I would personally want to get to as near real time as possible. And therefore, I want really a model that is function accurate to the last micro nanosecond. Easier said than done. I know that's not possible in the virtual world, but this is exactly the trade-off. So this is the balance that we need to bring between virtualization and the real world. And maybe my last, since there are no questions, my last statement, virtualization is a means to ease the real world problems. It is by no means replacement for what needs to happen in the real world. And therefore, a lot of what we are talking about is very specific to the need of the business, a need of the organization, and the need of that particular product. So we need to balance this out before we bring it to the market.
Yeah, thank you, Rasit. That was really enlightening what you presented to us. I think I also learned a lot of new things. To me, as I am coming from the hardware side of things, I was just at the hardware level, and the other things were not really on my mind. So thank you for enlightening me on this additional informations. As we speak about virtualization, I would like to invite you to join us in the virtual world, and also the audience to come to the virtual world and being able to talk to Satish further on questions that have not been asked or there was not enough time to be answered. So I encourage you to join the virtual world. We have now, I think, a little break until the program continues. So thanks again, Satish, for this great presentation, and see you in the virtual world.
Thank you so much for the opportunity. See you later. Bye-bye.
Bye-bye. With applause.